Welcome to the Microsoft Care Homes project. We are Team 14, and for the last 3 months we have been working on a full prediction system that could improve the lives of elderly people and reduce the cost for the NHS in treating injuries from falls. Our client is Paul Thomas. He works for Microsoft Services, Microsoft's public sector division. The goal of the project is to build a system that can aid elderly people and their carers by allowing them access to their fall risk statistic such that injuries from falls occur less frequently. Our team is formed of 3 second-year students: Andres Lucas Router, Andre Nika and Elliot Wise. From multiple meetings with our client, we have extracted a set of key requirements which we feel are necessary for the project to succeed. First of all, our system interface needs to be a simple design, similar to HealthVault, to allow our elderly user base to become comfortable with our system. Secondly, the system must provide a way of collecting data from the elderly people, either by having them insert it themselves or by using devices that are available on the market. Also, the collected data must be analysed to produce a viable statistic of the user's risk of falling. And finally, this calculated data has to be accessible by both the elderly users and the carers, or family members. We found that there are tests that can be used to assess falling risk. Tests like the Berg Balance Scale test or the test of functional reach can accurately predict whether a person is prone to a fall, but they have to be done in a special medical facility under medical supervision. On the other hand, we also found the timed up and go test and the turn 180 test, which not only can be done by the elderly themselves, but they also give an accurate prediction. Another method of predicting falls that we came across was the use of a smartphone to perform gait analysis. This requires a smartphone with a pre-installed application wrapped around the waist of the user and a pair of markers attached to their shoes. The information gathered from the smartphone's accelerometer and the camera helped to paint a picture of the user's gait. The issue with the solution is that it's very tedious to install the application around the user's waist. In addition, it behaves fairly fragile when the user makes abrupt movements. Other methods involving floor sensors or multiple cameras set around specifically designed rooms to gather information about people's gaits. However, these methods require a special setup and a presence of a specialist in gait analysis. We were suggested to look at wearables to help gather data. We did research in this field. Some of the sensory hardware we looked at was the Fitbit tracker and the Microsoft Band. However, these wearables are expensive and cannot provide a full picture of the user's body. An interesting device we found out about while doing research was the Microsoft Kinect. It has 3 different sensors, including an infrared camera, a depth field sensor, which can be used together with the color camera to give a 3D representation of the objects in front of it. It can also recognize users' faces and movements. Another advantage of it would be that it's very inexpensive. Finally, we have decided to follow the path of the manual test, which would allow us to create a system that could be used without prior special setup. However, we also needed to use some readily available hardware to improve the accuracy of the fall risk statistic. The Microsoft Kinect was suggested to us even before we started research, so it has been chosen as our primary automatic data collection device. We naturally researched into the use of the Kinect device to analyse our users' fall risk in a similar manner to the gait analysis. We found out about ways of reading the X, Y and Z coordinates of the user's joints, and we decided we could use this data to calculate the user's speed and balance. A problem we faced with the Kinect was that we were provided Xbox One Kinects, and we had to solder a USB onto these to get them to work with the PC. There was an online tutorial that we followed, which eventually, after a few hours of reading and soldering, led to us having a working Xbox One Connect that we could use with our computers. All this research was then brought together to form a final concept idea which integrated the use of several components. We came up with the idea of a fall prediction system that has 5 important components: Connect devices, desktop computer, desktop application, Microsoft Azure, web application. The main feature of the system is the collection of data from elderly people by using Connect devices. Whenever the device detects user movements, they start monitoring the person by collecting movement data. Next, the desktop application is responsible for extracting raw data from the Connect recordings, such as joint coordinates. These would be uploaded to the Azure cloud whenever there is an internet connection. Microsoft Azure is an important component. Firstly, it creates fall statistics by manipulating the data it receives from the Connect and the manual tests, which will be employed for the predicting falls later on. The cloud also has the role of being the host of the web application server. The web application allows the monitored person to access a personal account, where they can view their fall statistic, add manual test scores, or allow carers to view their data. It also allows carers or family members to access that person's data through a carer account. We have created a prototype of the described system which mainly focuses on the web application and the implementation of the database. We have chosen to develop the web application first because this represents the main way the user interacts with our system. Therefore, we concentrated on the following key features for the web application: the creation of 2 different types of accounts, a personal account for elderly users and a carer account for carers or family members, implementing different views for each type of account, allowing personal accounts to submit test scores, restricting personal accounts to submit only 1 score for each test each day, allowing personal accounts to view test score history. This is the home page of our application. As you can see, there are 2 different registration forms, one for creating a personal account and the other for creating a carer account. Registration for either account requires entering the user's first name, last name, email address and password, with 2 additional fields for the personal account: birth date and gender. For logging in, the user would then insert their email address and password and click sign in. Assuming the user details match with the database, the system then redirects the user to either a personal or a carer account page, depending on what type of account is linked to that specified email address. We will now log in with a personal account. As you can see, the personal page is loaded. In the top left corner, we can see the user's full name. Below that, we can find the different sections for the types of data of that account. Currently, the manual test section is implemented, but in future versions of this application, we hope to implement the other sections, like fall risk, balance, and speed. When we click on manual tests, the section extends, showing the different options available in that section. First is the test history, and then each of the different tests. When we click on a test name, the test view is displayed on the screen. The test instructions are shown below the test title. If we require more information about the selected test, we can click on the More Info link below the test name. A small window will pop up containing the description of the test. We thought this would be helpful since it helps elderly people to understand these tests are not randomly picked. As a result, it is more likely that they will believe in the importance of the tests and therefore do them on a regular basis. For submitting a test score, we simply insert a score value inside the input field and click Submit. The test score has now been submitted. If we try to submit another score for that test, the system will let us know that we have already submitted a score today and cannot submit another score. If we want to see the test history, we simply click on the test history section. Previous test scores for each test are displayed in the separate tables. In later versions, we hope to implement a messaging feature between personal accounts and other accounts, as well as a notification feature for alerts such as new access requests and increasing fall risk notifications. Now we will go to the top right corner and log out. We will now log in with a carer account. This is the carer view. It has two sections, the dashboard and the checklist. The checklist contains the personal accounts that this carer has access to. In future versions, we would like the dashboard to display a list of patients from the checklist that have increased fall risk and may require more attention. When we click on the checklist, the list of linked personal accounts appears. If we want to check the information about a personal account, we click on that person's name. This will load up a screen where the latest analysis of that account is shown. Currently, we can only view a history of manual test scores. For doing that, we have to click on the test scores section and the current history of scores for that personal account is shown. If we want to view information about another account, we simply click on the account name in the checklist and select the desired section. It should be noted that the top right navigation bar will be sharing the same functionalities in the personal account and the carer's account. Now we will go to the top right corner and log out again. You will see here that we have added an edit profile and a settings option. This allows the user to edit their profile details such as their name and age, and the settings option is for changing account related topics. Currently, we have managed to achieve a successful system idea to solve the issue we were presented. And we have created a prototype web application that shows the main functionality of our system. For the future, we plan to focus on the fall prediction component of our system. In other words, we need to develop the desktop application which extracts data from the Connect device recordings, and the web application, which will display useful data calculated on the Microsoft Azure cloud. Each development step will be followed by extensive debugging and testing steps. In the end, we are going to deliver our full-fledged proof of concept to the client and show him our final prototype. Microsoft Care Homes would like to thank you for watching, and we wish you a Merry Christmas and a Happy New Year.